All right, this is Unit 6, and the title will be Trigonometry. And these notes are going to be on page 51 over the geometric mean. So let's turn to page 51 in your notes and title that page Geometric Mean with the page number 51. And we're going to start by drawing the circle that you had drawn when we were talking about the geometric mean in class. So we're going to draw in a diameter, and we're going to draw in a radius and a chord that is perpendicular to the diameter. All right, and then we want to label this part of our line A, the little piece of our diameter B. We'll give the radius the letter D, and our chord will be letter C. Okay, and just draw yourself a thought bubble to remind yourself that we had drawn in a diameter. Okay. First of all, we talked about the arithmetic mean. And remember that that was just an average, like we had already been finding in math. So in order to keep all of this straight, let's go ahead and do some highlighting. I'm going to choose pink for A, orange for B, green for D, and let's make C yellow. Okay. So when we are going to find an average, we're going to add A plus B and divide by 2. And when we do this, we will get our whole diameter divided by 2 gives us a radius, so that will give us the length of D. So I'm going to highlight in my equation as well. A plus B divided by 2 gives us D. So instead of finding the arithmetic mean, we're going to start looking at finding the geometric mean. So we have two different ways that we can write the equation for the geometric mean. We can use our relationships in chords. A times B equals D times D. Oops. Or A times B equals C times C. Let's use that one. We're going to write that as A times B equals C squared. Or we can write it as the square root of A times B equals C. And I'm going to go back through and highlight those as well, just so that if I want to use these formulas, I can refer back to the picture and find exactly where these numbers should come from the diagram. Okay. I'm going to draw myself two more thought bubbles to remind myself that in the arithmetic mean we found the radius, and in the geometric mean we found a chord. Okay. Remember that in class we learned that the arithmetic mean will always be greater than or equal to the geometric mean. And that's just saying that anytime we have a segment that goes from the edge of the circle to the diameter perpendicular, that the radius will be the longest of any of those segments anywhere along that line. All right, so let's do some examples. Okay, so example number 1, let's go ahead and draw ourselves a circle with a diameter. And I'm going to sketch in this right triangle here as well. So we know that this part is 5, this part is 3, and that segment is the segment we are looking for, so we're going to call that segment X. So if we are looking for this piece, that is like our C in our diagram above. So since we want to find C, I'm going to use this second equation, A times B, and the square root of that will give us C. So in this problem, A is 5, times B is 3, and that should equal X when we find the square root of that. So we can multiply 5 times 3 and get the square root of 15. And 15 does not simplify. The square root of 15 does not simplify, so we can just leave it as the square root of 15. Example 2. This problem, I'm going to start with a triangle. So I'm going to start with this right triangle, and we're going to know that this part is 8, this piece is 4, and we're looking for that piece up there. So when you have a triangle problem that you're trying to find a missing length, we can imagine this triangle inside of a circle. So I'm going to go ahead and sketch in what that circle might look like. And no, it's not going to be perfect, and that's okay. And if we wanted, we could draw in that little dashed line to remind ourselves to think about this as a problem where we know that both of these pieces are 8. So I'm going to choose to use our first example equation because in this problem, A is our X and B is 4, and the thing C is 8. So if we use this equation, we have X times 4 equals 8 squared. Or, excuse me, X times 4 equals 64. Divide both sides by 4, and X equals 16. So depending on which information you have will decide which of those two equations you want to use. However, it doesn't really matter which one you start with. So if I had started, for example, in example 1 with the first equation, 5 times 3 equals X squared, well, the inverse of squaring, the only way to get rid of that square is to take the square root of both sides. So I would end up square rooting that regardless, and I would end up exactly with that second equation.